Skippy, we're back. All right, chapter 20, questions for study and discussion. So, how does MIG differ from TIG? Well, MIG was developed to increase the speed in which we could deposit metal. MIG differs from TIG by the speed of deposition rate. There's no flux, and the spatter that's produced. There's also deeper penetration. Okay? At what work angle should the welding gun be for horizontal fillet? Well, we talked about this. This is going to be 45 degrees. And what work angle should be the gun for flat fillet? That's going to be 90 degrees for our work angle. And our travel angle should be 10 to 20 degrees. Now, what determines whether we push or pull? Well, when we pull, we have deeper penetration. Okay? And pulling also makes it easier to see the weld pool. Okay? When we push, it allows for faster travel speeds. It's a lot less penetration, and the weld is going to be a lot wider. So pushing is used for thin metals to prevent melt through. Oh, now, keep it moving. Come back. All right, so what's the difference between spray transfer and globular transfer? So globular transfer is a transfer of molten metal in large drops. And the welding wire, from the welding wire across an arc to the workpiece, spray transfer is the mode in which welding wire is propelled axially across the weld. So why is globular transfer ineffective for heavy gauge metals? Well, it's ineffective because the arc is really poor. There's poor penetration. There's a lot of spatter. It needs a lot of cleanup. And you can only do it in flat and horizontal fillet welds. So it's not really effective. So what is meant by short-circuiting transfer? And for what type of weld is this most effective? So short circuit, or GMAWS, is the transfer mode where molten metal is deposited during repeated short circuits. Low heat input is associated with GMAWS, and it is suitable for thin gauge metals up to 1/4 inch. GMAWS can be used in all welding positions because it produces a small, fast freezing weld pool. So what is the probable cause for the formation of overlap? Overlap usually happens when the arc doesn't melt the base metal enough. It causes the weld pool to flow into unmelted areas of the base metal without fusing. So it occurs when the weld pool gets too big. Okay? All right, so what should be done to prevent surface porosity? Well, surface porosity is the result of atmospheric contamination. Atmospheric contamination occurs if the shielding gas is too low or too high, if the shielding level is too low, so the arc in the area is not fully displaced. Okay? So if the shielding gas is too high, it causes turbulence and it draws air into it. Or if we're in a windy area, maybe even a fan. So without having good shielding, we're going to get porosity. So how can we prevent porosity or cracks? So crater cracks can be prevented by good housekeeping, right? We want to make sure everything is clean, and we want to make sure that we fill in the end of our weld. In addition, porosity is caused by poor housekeeping, which means we want to make sure that everything is clean. All right, so what should be done if weld penetration is insufficient? Well, we know that insufficient penetration is due to low heat input. So we want to make sure that we turn up the heat. All right, guys, take care.